Please make sure you have your copy of the assignment Calorimetry, Energy in Fuel and Food. There are 2 parts to this lab. We'll do the first part today and we'll do the second part tomorrow. So please take a look with me at the procedures on the back of the first page for part 1, Energy in Fuel. What we're going to do here is we're going to find out how much energy there is in each gram of candle paraffin, the fuel that makes candles burn. We're going to exchange heat with a calorimeter made from an open aluminum can. And then we'll use the calorimetry calculations we've used before to figure out how much heat was exchanged for each gram of material that was burned. Now, a couple things about the calorimeters that we're using. Now, before we used a calorimeter that was closed and insulated so that all heat exchange took place inside. But since we're going to be burning things, that won't be possible inside of a styrofoam cup. So when we burn things below our calorimeters and the heat escapes and goes into the can and heats up the water that's in the can and also the metal that's in the can, a lot of the heat is going to get lost. So some of our results are going to be inaccurate. But if we know the result that we should get for paraffin, it's a known quantity, then we can calculate how inaccurate our results are, and we can use them to devise a correction factor. So that in the second part of the experiment, when we do the same procedures using a piece of food, in this case a Flamin' Hot, then we can apply that correction factor to hopefully take away the source of inaccuracy. So, looking at the procedures. First step, you'll have a baking cup and a candle, and you want to put those on the balance to find their mass, the starting mass of the candle. As it burns, the material is going to be used up and it should weigh less when we're done. And then we'll put that down, and then when you're ready, let me know. I'll come by and light your fire. But first, make sure that you read the starting temperature of the water inside the calorimeter and record that. Now when I light your fire, you're going to want to get your calorimeter down close to the candle so you can lower it down, and you want to get as much of the heat into the can as possible without putting out the flame. So that's the purpose of having the aluminum foil cup there. That's to help reflect the heat up into the can. And what you want to do is watch the thermometer, and you want to watch the temperature rise, and you want to let the temperature increase about 30 degrees Celsius higher than its starting point. That doesn't mean stop at 30 degrees, that means go 30 degrees higher than where it started. So if it started at 25 degrees, then you would let it go up to 55 degrees, which would be an extra 30 degrees Celsius. Once the temperature has reached the high point that you're looking for, then you can blow out the flame, and you can put the material back on the balance and reweigh it. It should weigh less than it weighed before. Subtract to find out how much fuel was used, and then we'll do calculations to find out how much heat was exchanged. We'll have to account for 2 things that are exchanging heat with the candle. One is the aluminum can, and the other is the water that's inside. So we'll do a calculation for heat exchange with both of them, and then we'll add them together to get the total result.